Hello and welcome to the sixth part of the Divine Skins Wiki tutorial series. In this episode, we're going to take things a step further and dive into building and triggering your own particles. First, I'll show you how to copy and paste a full particle system, like Set's ultimate area effect, into your own bin file. This means we'll be creating a custom particle system based on an existing one. Then we'll move on to the animation bin. We'll learn how to trigger Set's ultimate visual effect during Chiana's recall animation. This includes learning how to use animation events like particle triggers and visibility toggles. After that, we'll take a look at persistent effect conditions, and I'll show you how to trigger Set's ultimate using those as well. Let's get started. First, let's start by extracting Set's WAD file. We need it because it contains both the textures and the bin file for his ultimate effect. Once extracted, go into the characters folder and open Set's folder. Now delete the HUD folder. We won't need it. Also, remove every skin folder except for skin 0, which is the base skin. That's the one we'll be using. Next, go back to the characters folder and drag and drop Set's entire folder into your mod. In this case, we're placing it inside Chiana's characters folder since that's the champion we're modifying. After that, open both skin 0 bin files, one from Set and one from Chiana, because we're going to copy the particle system from Set's bin and paste it into Chiana's. Let's get started. Before we start, I recommend installing the Python extension in Visual Studio Code if you haven't already. To do this, click on the extension symbol on the left side of the screen, then search for Python and install the official Python extension by Microsoft. This extension makes working with bin files much easier. It shows the structure of the file, meaning you can see all the major blocks, like VFX systems or idle particles, listed at the top. If you click on one of these names, Visual Studio Code will automatically scroll and jump to the right section in your file. It's a super handy tool that will save you a lot of time when navigating through long bins. Moving on, let's search for Set's ultimate effect inside his bin file. Once you find it, copy the entire particle system block. Make sure you grab everything inside the purple brackets. You can see at the top when the particle system ends. Now switch over to Chiana's bin and paste the particle system in between the other VFX system definition data blocks. After placing it, we want to rename the particle system. As we already covered earlier, you can give it any name you want, and it's actually a good idea to rename it so it's easier to organize and recognize later. After you rename it, don't forget to register your new particle system inside the resource resolver. If you skip this step, the game won't be able to find or trigger the effect properly. Now let's go through the animation bin. At the top, you'll see animation names like Attack 1 or Spell 4. These represent different actions in-game. For example, Attack 1 is the animation for your auto attack, and Spell 4 is usually your ultimate ability. In this tutorial, we want to trigger Set's ultimate effect while Chiana is recalling. So let's start by searching for the recall animation. The first thing we need to check is whether the animation has something called an event data map. If your animation doesn't have this section, it won't be able to trigger any events like particles or submesh changes. If it's missing, just add a new event data map to the animation block. Once inside the event data map, the first thing you'll notice is a green-colored name. These are hash names. They're used when the original name couldn't be translated by Ridabin during conversion. Don't worry too much about them. You can replace them with your own name. Inside the event data map, you might see something called submesh visibility event data. As the name suggests, this lets you show or hide a specific submesh during an animation. If you remember from the earlier tutorial, we talked about how you can hide a submesh for the entire game, and then make it visible only during a specific animation. This is exactly how you trigger that. You'll see a start frame, which is the frame during the animation when the visibility change begins. You can also set an end frame, so the submesh stays visible for just a part of the animation and then hides again when that frame ends. In this example, I'll create a cube in Maya and show you what it would look like if we would set the start frame at frame 60 and the end frame at frame 120. Right below that, you'll probably see a sound event data. This is used to trigger a sound. But for now, we're going to skip that part. Now on to the most important section, the reason we're in this bin in the first place, a particle event data. This works just like the submesh visibility section. But instead of showing a mesh, it triggers a particle system to spawn. You can name this block however you want, and then inside it, you'll set the effect key to the short name of the particle system you want to use. In this case, we'll use the name test_VFX, which we previously defined in the main bin and registered in the resource resolver. You'll also see a bone name field. This tells the game where to spawn the particle, like on the hand, head, or weapon. That's especially useful for attaching effects to movement or attacks. Once everything is set up, let's hop in game and test it. You can also trigger specific things in-game using something called persistent effect conditions. This code is placed under skin character data properties, specifically beneath the M resource resolver link. Persistent effect conditions are basically logic conditions. They check whether something is happening, like an animation playing, and if that condition is true, they trigger a visual effect. In the example we're using, the condition is called is_animation_playing dynamic material bool driver. That sounds complicated, but it's pretty simple. It just checks if a specific animation is playing, in this case, the recall animation. If the condition is true, meaning the recall is currently happening, then the effect defined in persistent VFX will be activated. At the bottom of this block, we can define our VFX. We assign a bone name, which tells the game where the particle will be attached, and an effect key, which should match the name of your registered particle system. This is another way to trigger particles without needing to use the animation bin. It's especially useful for applying passive auras or special effects tied to things like transformation animations, skins, or state-based visuals. Persistent effect conditions can also be used for things like form swaps by simply hiding one submesh and showing another when a condition is met. In this example, we're using something called a delayed bool material driver. This adds a delay to the effect after a condition becomes true. The main condition here is an is_animation_playing dynamic material bool driver, which checks whether one of the listed animations is currently playing, like spell 4. If one of these animations is triggered, the condition activates. But thanks to the delayed bool material driver, the visibility change lasts even after the animation ends. M delay on is set to 0, so the effect starts right away. M delay off is set to 20, which means the effect will stay active for 20 seconds before turning off below. That we have submeshes to show. This makes gear 5 visible. The white cloud form submeshes to hide. This hides gear 4, the muscle. This system is often referred to as fake gear data in the modding community. That's because Riot uses something called gear data to swap things like meshes or particle systems dynamically, for example, during Katarina's Battle Queen dagger switch or ultimate particle changes. However, real gear data is server-sided, meaning we can't use it in custom skins or local mods. So instead, we simulate the effect using persistent effect conditions and visibility swaps. And that's why we call it fake gear data. And that wraps up the 6th part of the Divine Skins Wiki tutorial series. Today, we learned how to copy a particle system from another champion into our own bin, how to make it completely ours by renaming and registering it, how to trigger that particle system during an animation, and we also explored persistent effect conditions, a powerful tool for creating form swaps and time visual effects. Thanks for watching, and I'll see you in the next part of the series.